Okay. So we have a question. Ethane reacts with chlorine to form chloroethane. So first of all, this is the equation that has been written. And first of all, we are not going to do this question because we are not discussing with the enthalpy changes right now. Let's move towards question number two. State the condition needed for this reaction to occur. So first of all, we know that this is basically free radical substitution reaction. Reaction In this reaction, uh, what we need for the reaction to occur, so that is basically UV light. In the presence of a UV light, this reaction will occur, but in darkness, this reaction would not proceed. So this is UV light. Use a series of equations to describe the mechanism of this reaction, including the names of each stage and an indication of how butane can be produced as a minor product. So we have to write just the equations, okay? So first of all, we know for these reaction, the first reaction is, Sultan, what is the first reaction? That is
Initiation.
initiation, in which what is going to happen, this chlorine molecule is first split up in under the presence of UV light into radicals, into free radicals. Okay, so these are basically free radicals. And we have also discussed this thing. What kind of fission is this one?
Homolytic.
Yes, homolytic fission, because you can see that one electron is basically present on each chlorine. So this is basically a homolytic fission. And then proceed towards propagation. As you know, the next step is propagation. So what is going to happen around there? Just wait. Okay, so let's move towards propagation. So what is going to happen in propagation? That first of all, this is basically ethane molecule, and this is going to react with this free radical. So what is going to form around there? That would another free radical, which is formed C2H5, and let's put a dot on this carbon here. And what is going to form along with it? That is HCl.
HCl.
Yes, great. And in the next step, what is going to happen? This free radical, this would be C2H5, and it would react with this chlorine molecule. And what is going to form? This chlorine would react with this one. Okay, it would break. This would react with this one and would be forming C2H5 Cl with the free radical, which is this one, would be formed. Okay.
So it
And
forms a halogen alkane.
yes, that would form halogen alkane. This is halogen alkane. Okay. And now what is going to happen? This C2H5 molecule, we know this is basically free radical in the last termination reaction. Always remember one thing in termination reaction, that the radicals, they are going to combine at this position. So we know we have this radical. So that is going to combine with the same radical. And what is going to happen? It is going to form C4H10. So basically what they have asked us for, how butane can be formed as minor product. So this is the way through which a butane would be formed as a final product. Okay. So there are some other termination reaction that is also going to take place. That is C2H5. This radical is going to combine with another radical, this one. And now what is going to happen? C2H5Cl would also form. So is that clear, Sultan?
Yeah.
Okay, so let's move towards the next question, and that is when chloroethane can be converted back into ethane by a two-stage process when intermediate compound X. So, in the last class, we have discussed with halogen alkane. So, first of all, what do you think that what is going to form in this two-stage reaction? How this has been basically converted to this one. Yes, do you know any method? Do you remember the halogen alkane have some reaction with alcoholic sodium hydroxide? Do you remember that? What kind of reaction that would be?
Is it hydrolysis?
No, 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 that is not hydrolysis. Do you remember one thing? That there is an intermediate ethene is formed. Ethene is formed. How a halogen alkane make ethene? There was a reaction I have told you, and that is elimination reaction. Now understand? Elimination reaction
Yeah.
that occurs basically in the presence of alcoholic sodium hydroxide. This was alcoholic sodium hydroxide. Okay. So what is going to form here? There was a double bond, and that was ethene basically was formed here, and suggest the reagent and the condition needed for reaction one. So what is the reagent and the condition needed for reaction one? Yes, reagent must be,
Alcoholic.
yes, alcoholic.
Alcoholic metal hydroxide.
Yes. And what is another condition for that? I have told you about, do you remember about the condenser, about that evaporation, the vapors that is formed? So what was that?
Reflux.
Heat reflux. Heat reflux. Suggest the reagent and condition needed for reaction 2. So now here C2H4 is formed. Basically, if you will see this, C2H4 is already formed here. And when it is going to react with something, what is going to react here? So C2H6 would form. What do you think? What we have added in this ethene molecule? Yes.
H2.
Yes, H2. So that occurs in the presence of, yes. What is the catalyst in this kind of reaction? That's
Which will be
that is nickel catalyst or platinum catalyst. Okay. In this
okay.
reaction, and this reaction is basically called as hydrogenation. Okay.
Okay.
So this occurs in the present reagents are H2 and the conditions are platinum and nickel. Okay.
Okay.
Okay. Haptene is an undesirable component of petrol as it burns explosively causing knocking in an engine. There are nine structural isomers with formula C7816, only two of which contain chiral centers. Okay, so explain the meaning of the term structural isomer and chiral. So what is structural isomer?
When they have the same structural formula, the same molecular formula, but different structural formula.
Great, same molecular formula, but different structural formula. Okay, and what do you mean by chiral?
When an carbon is bonded to four different functional groups or
When
four
carbon,
different atoms.
great, when carbon is bonded to four different functional group or atoms. So Give the structure and names of two structural isomers which contain a chiral center. So what could be two structural isomers would be? So if you see how many carbons would be there in heptane, there are 7 carbons. So if we do that, like if we draw just 6 carbons like this, okay, 1, 2, 3, 4, 5. Now it's 6. So if we draw a methyl group on third carbon here, or even the fourth carbon, that is fine as well. So if we draw this here, okay, and remaining we are going to draw hydrogen like this, okay. So what is going to happen around there? Yes, Pete, what is going to happen? Do you think, is it a chiral? Is there any carbon which is chiral here?
Yes, the
Yes,
third one.
great. So this one is basically, you can see this one is chiral. This one is chiral. So आप देख सकते हैं the whole molecule here is basically different. This one and this molecule is also different. This part, sorry, this part is different and this is also different. This is also different. So you can see that in this isomer, we have got one chiral center. So let's move further towards the next part. Now, if we draw another isomer for this one, then how we are going to do that? Now, you can draw about 5 carbons. Total, we have 6 carbons. If we are drawing 5 carbons and we are putting this methyl group here and methyl group here, so what is going to happen? Now we are also going to have chiral carbons. We are going to have chiral carbons. So, bete, do you think this one is chiral?
Um,
This one is chiral,
Yes, it is, and
and
I
this one,
think the third one as well is carbon.
yes, this one is also chiral. Okay. So write an equation. So this question is done. Write an equation for the complete combustion of heptane. Yes. How we are going
Um,
to write the equation for heptane? So simply
yeah, so
C7H16.
C7H16 plus 11O2
Okay.
equals 7CO2
Okay.
plus 8H2O.
Okay. Uh, First of all, Sultan, the best practice to write down this equation is, first of all, we have to write this combustion reaction. If they have not described whether it's a complete combustion or an incomplete combustion, so you have to consider it as a complete combustion. So we have written this equation. Now we are going to balance it. We are going to put 7 here and we are going to put 8 here. So how many oxygens would be there? 14 plus 8, that is 22. So we are going to put 11 here. Okay. So this must be the sequence to write. Write an equation for the incomplete combustion of heptane leading to the production of solid pollutant. So first of all, they are asking that if incomplete combustion occurs, I have told you if incomplete combustion occur, there are basically some equations, incomplete combustions. So what are those equations? Like, first of all, C7H16 is there plus O2. First of all, carbon monoxide is formed and water is formed. This can be done. And if they are asking about solid pollutant, then there must be carbon which is produced. So this is the second equation for incomplete combustion. And the third equation is C7H16 plus O2. Third equation is carbon monoxide is basically react and carbon plus water is formed. Okay. So these are basically three equations that we can use for incomplete combustion. But here they have told us that a solid pollutant is formed. So I'm going to use,
So here's the second one.
yes. So say C7H16 plus O2, carbon plus water. So it's 7 and 8 is there. 8 and so it's total 8. So what is going I'm going to put here? Okay. So
Um,
income.
so
Next question, please. G.
okay.
Yes, please
No,
read.
no, nothing, nothing, nothing.
Okay. Read out the next question and answer me.
Okay. Incomplete combustion can also lead to emission of unburnt hydrocarbons. State one environmental consequence of this.
Yes,
So I think it's global warming.
great. So global warming is the right answer. Crude oil is a mixture of hydrocarbons and provides many useful chemicals when processed. Two of the stages involved in the processing of crude oil are fractional distillation and cracking. The diagram is a simplified representation of a fractional distillation column. Okay. Now, uh, two of the stages, the diagram is a simplified. Okay, what has to be done to the crude oil before it enters the column? So, what should be done to the crude oil before it enters this distillation column? This is basically called as distillation column. Yes, what has to be done with crude oil?
Um, um, Before it goes into the column, it has to be heated up?
Yes, it has to be heated. So what trends in structure is there from fraction A to fraction F? So what is the effect on structure of carbon? First of all, I just want to tell you, at the top we are getting lighter fraction. Lighter fraction means the one with less number of carbon atoms. Okay. And at bottom we are getting higher fractions. What are higher fractions? That contains greater number of carbon atoms. ठीक है?
Okay.
So, what trend in structure is there from fraction A to fraction F? Yes, what is trend in structure?
Longer chains down the column.
Great, or you can say increasing number of carbon atoms. Or longer chain is also fine. ठीक है? State the trends in two properties of the fraction from A to F. Remember, at the top, uh, we are getting the fractions which have less density, which have less boiling point, which are more volatile, and you can say low boiling point, low viscosity. So at bottom, we are getting high density, we are getting high boiling point, we are getting less volatility, and we are getting more viscous liquids. Okay. So what is the trend in two properties of the fractions from A to F? We can take any that more density or greater boiling point. Okay.
Okay.
So naphtha fractions from fractional distillation of crude oil is used as a starting material for cracking. Write an equation for the cracking of C12H26 to form the product ethene and one other hydrocarbon in a 2:1 mole ratio. So what is going to happen? We have to write the cracking equation of C12H26. They told us that ethene is going to form in the product side. Ethene is this one, and it is in the ratio of 2:1. So ethene has the ratio of 2. Okay, 2 moles for this. And definitely the other one would be having 1 mole. So how many carbons are left now? it becomes C4, so remaining is C8, and it's 8, so it becomes C8H18. Okay, so this is basically our final answer. So most vehicles fuels contain hydrocarbons obtained from crude oil. State the name of the type of reaction that hydrocarbon undergo when being used as a fuel. Yes. So what kind of reactions hydrocarbons would undergo when they are used as a fuel?
Is it combustion?
Yes, it is a combustion reaction. Write an equation for the reaction of octane as a fuel. So we just have to write the combustion reaction. It's quite simple. That would be forming carbon dioxide, water. Now balance it. 8 should be come here, and in order to balance it, 9 should come here. The supply of material processed for use as a fuel directly from crude oil is not sufficient to meet demand. A process is carried out to make some of the larger hydrocarbons more useful. I have told you before that there are some larger hydrocarbons which are less useful. Okay, larger hydrocarbons are less useful. That are basically, you can say, kerosene, that has less use as compared to petrol. Petrol, which is small hydrocarbon. Okay, that is small hydrocarbon. So what is going to happen? There is a process which convert large hydrocarbon to small hydrocarbon. That process is called as, yes,
Cracking.
yes, that is cracking. Draw the now, as well as producing fuel, this process produce compounds suitable for use in the production of polymers. An example of such a compound is butene. So draw the repeating unit of the polymer that is produced from butene. Okay, so first of all, remember this thing, how we have to write it. First, we have to write it in the structural form, and that is carbon is this, hydrogen, and CH3 comes here. Double bond is over there. So they are going to write hydrogen here and CH3 here. When they would be polymerized, when they are polymerized, so what is going to happen? This double bond is converted into single bond like this. And these units, this is basically a monomer. And when they are polymerized, so they are going to form the repeating unit with single bond. So this is basically the repeating unit among them. Is that clear, Sultan?
Yeah.
So this is repeating unit. So we just need to write this repeating unit here. Okay, let's move towards next question. Kindly read out the question.
Name the type of polymerization that occurs during the production of the polymer in II.
Yes, so
In
what
two.
kind of this polymerization to be called as? This is called as addition polymerization. Okay, addition
Okay.
polymerization, in which monomers are basically polymerized and would be forming the polymer. Addition polymerization. Is that clear?
Yeah.
So gases produced in internal combustion engine, including carbon monoxide, oxides of nitrogen such as NO2, and uh, unburnt hydrocarbons. State what is used to remove these gases from the exhaust. Remember, in the car exhaust, there is a converter which is named as catalytic converter, whose purpose is basically to convert this carbon monoxide that has been produced due to incomplete combustion and nitrogen monoxide. They are going to react together to form nitrogen and carbon dioxide. Okay, so this is catalytic converter. Write an equation to show both carbon monoxide and nitrogen dioxide are removed from the exhaust. So what is going to happen? This carbon monoxide is going to react with this nitrogen dioxide, and they are going to form nitrogen plus carbon dioxide is formed. So we have to just balance it. So we are going to put 2 here, and in order to balance it, we are going to put 2 here. And do you think it's balanced now?
Yeah.
No, because there are 4 carbons, so we are going to put 2 here as well and 2 here as well. Now it seems to be balanced. State the environmental
Oh yeah.
consequences of allowing unburnt hydrocarbons to enter the atmosphere. So you have already discussed this thing. That would be,
Global warming.
yes, global warming, and that could either be a smoke as well. Okay.
Okay.
Hydrogen, basically we have given this molecule, and now what they are trying to say, just okay, now it's fine. So H reacts with, this is H, and it basically reacts with cold acidified potassium manganate with hot concentrated acidified. Okay. Give the structure of organic product of the reaction with cold dilute acidified potassium manganate. Do you remember for cold dilute acidified potassium manganate, I have told you what is going to happen around there?
Um, is can't remember actually.
Do you remember I have told you only sigma bond will break here. Bond will break. And
Oh, oh yeah.
what is going to happen, Sultan, here? That C double
Um,
bond C, this is CH3, and this is CH3. This is you can say CH3, and this is CH2OH. Then what is going to happen? We are adding oxygen, potassium manganate. It is giving oxygens and water. What is going to happen? 2OH group is going to attach here. Okay, for cold
yeah.
acidified potassium manganate. So let's see what is going to happen. This CH3 and OH group would form here. This is CH2OH, CH3, and OH group would form here as well. Give the structure of organic product of the reaction of H with hot concentrated acidified potassium manganate. So बेटे
So
hot से
I
मैंने क्या
think I
कहते
know.
थे? हाँ हाँ बताओ.
Um, both the pi and the sigma bond will break, and if
Okay.
the double bond H has two carbons, then CO2 will form, and if
Two hydrogen, Sultan, two hydrogen. If there is two hydrogen here or here, then what is going to happen? CO2 is formed. If
CO2
there
will
is,
form,
if there is only one hydrogen or other group, so there is other
carboxylic
group here.
acid will form.
Yes, so carboxylic acid would form at this position, and what is formed here? What is going to form here? You can see that there is no hydrogen here. So what is going to form here?
Ketone.
Very good. C double bond O dash CH3. So this is ketone which is going to form at this place. And on the other place, what is going to form? Carboxylic acid, as it has only one alkyl group here. Okay.
Yeah.
So let's move towards the next part and let's see what is going to happen. Complete the reaction scheme to show the mechanism of reaction H with bromine to form J. Okay, so what is going to happen when this double bonded compound is coming near to this place? Then what is going to happen? We have discussed this thing that they started to become polar. A partial positive charge is created at this place and a partial negative charge is created at this place. So the okay, so what is going to happen when this you can say double bond is coming near to this bromine? Then due to the electron density, what is going to happen? Partial positive charge is created here. A partial negative charge is created here. So what is going to happen? the structure would become like this. Okay. And Br comes here. As you can see, this double bond, two electrons that has been shifted at this place. So what is going to happen? CH2OH would come here. CH3 would come here. And there's a radical at this place. Is that clear? Or you can see
Yeah.
the positive charge. It should be a positive charge. We can write it like this. So now, what is going to happen? A bromine molecule with two lone pairs and a negative charge that is going to strike at this place, and thus this structure would form. Okay,
Okay.
why the why the dipole is basically created on bromine molecule? So we have seen this thing that basically this is carbon, double bond carbon, and this is CH3. So this is CH2OH and this is CH3. And when they are coming near to bromine, so we have seen this thing that a partial positive charge is created here, partial negative charge is created here. Why? As I have told you, the carbon is having the structure like this. Okay, there is this sharing of electron at this place, and the other electron is basically shared like this. The pi bond, for pi bond, I have told you the electron density is basically spread like this. Okay, so you can see why a pi bond is weaker, because electron density is spread around it. Okay, so electron density is spread around it. Electron can be at this position, at this position, at this position, at this position, anywhere. So you can see that pi bond is basically, first of all, more reactive. This is the reason. And what is actually happens, why this dipole is created at bromine? Because dipole is induced by electron density. So this dipole is induced by electron density. Is that clear?
Yeah.
State the type of isomerism shown by J. So what kind of isomerism that would be, that is shown by J? Let me just see. Okay. So this is basically a molecule. Can you please tell me that what kind of isomerism is basically shown at this place? At this place, you can see
At which
that
place?
at in this molecule, in this J, in this J.
Yeah.
Can you please tell me what kind of isomerism that would be?
Is it cis?
No, it's not cis, because cis or trans isomerism must need to have a double bond in them. Don't you think so? It would be a stereoisomer,
Oh, okay, yeah.
है ना? Stereoisomer,
Yeah.
isomer. Why? Because of this carbon, like they are basically chiral. They are chiral, okay, because they are bonded to different groups. So that is basically chiral. So that is why we can see that it is going to have stereoisomerism. Okay?
Okay.
And they want us to draw the structure of two isomers of J. You know that the isomers, which is basically optical isomer, and if they are going to have the mirror in them, so what is going to happen? First of all, let's draw the structure, and that is carbon. Uh, so we have CH3, CH3Br. This is C carbon, CH3, CH3. And we have Br here, we have C here, we have CH2OH here, we have Br here, and we have CH3 here. I hope this is the structure. Yes, so this is the structure. So how we are going to show them in a stereoisomer place? So we know that in stereoisomers, they are basically non-superimposed non-superimposed mirror image of each other. Okay, we know this thing. So how this structure is going to form? Carbon at the top, that would be bromine CH3, that would be CH3, and that is C. At the top, there would be CH2OH, and it is going out of the paper into the paper, and that is this CH3, and this Br would be here. Okay, first structure would be like this. And in second structure, you know that they are the right side of the molecule that would come on the left hand side. So this is basically right hand side and this is left hand side. So they are going to be changed. Okay. So what is going to form? This would be CH2OH would come here, and this CH3 would come at this place. Br would come at this place, okay, and there would be the carbon like this. So it would form C. Br would be at the top, like we can see here, Br at the top. And at bottom, there would be CH3 like this, and CH3 would be like this. Is that clear, Sultan?
Yeah.
So right hand side has been gone to left hand side when they are basically placed between the mirror, okay?